So I thought today we'd start taking a look at this UEI oscilloscope Model 301. This is yet another item I picked up at a local electronics recycler. I've removed the skins from the case already to take a peek inside. I'll give you a quick tour here. We'll talk about safety and some other things. As we tear into this, I haven't decided how far I will go with repair on this. I'd like to get it going. It would make an interesting maybe scope clock if it was cleaned up. Might make an interesting little XY monitor of some kind. It's fairly hammered. If you can see here, the vertical sync and sweep controls, the entire metal chassis inside is offset. They are jammed up tight against the sheet metal they poke through. It's got these oddball, I guess they were common maybe in the era, binding posts. It's got the ground binding post broke off. There was some rust on the external skin, and it rattled quite excessively when I picked it up. Well, let's go ahead and flip it over and take a look under the chassis. So the rattling in the chassis turned out to be this 0.25 microfarad 600 volt capacitor that had broken completely off and was loose inside of the case. One side of it was connected to here originally, the side that's broke off. I have lifted actually a couple of other caps just to make some measurements inside. I have not powered this guy up yet. As you can see, it's point-to-point construction, as is quite typical from this era. We of course have the ground input down here and the vertical input here, which comes in through a DC blocking cap. So it's really only capable of looking at AC signals. The horizontal comes into a switch here, which external sync and internal. It's kind of interesting to see. It's got both internal and external sync. This entire sub-chassis along here with the pots on it is the part that has been pushed offset somehow, causing these to bind really tightly. I'm going to have to mechanically tear it down to realign that. The quality of the soldering is pretty piss poor overall. It definitely looks like something that was, assembled as part of a TV service course, perhaps. I did find a manual online for it, so I've got the schematic, etc. If I can find the link again, I'll post it. A gentleman was nice enough to email the PDF to me. So it is what it is. We can be pretty sure that these electrolytic caps over here, at least I'm pretty positive these paper caps are double cap electrolytics, will need to be replaced. I'm guessing this guy will need to be replaced. It's some kind of I don't think it's wax film, but it's certainly not a great capacitor. We've got another, I'm guessing is an electrolytic buried down here. Of course, the word's not going to come to me. Anyhow, these guys should be good. I don't see any like burnt resistors. That's a mica capacitor. These guys are mica. If we could see onto the face, there'd be some colored dots that would give us an indication of what type of capacitor they are. There are some silicon diodes in here. There's a couple here, one up here. Which is interesting. So it's a mix of semiconductor and tube. Be interesting to see it come back to life. I've debated whether to completely strip it down and rebuild it from the ground up versus just do enough to get it working. I really haven't decided yet how I'm going to approach it. I do want to talk a little bit about safety. You'll notice where the line cord comes in here, of course. It would be 120 volts in the US AC across these terminals. Obviously a dangerous shock point. There's going to be high voltages in here on the various tubes and the CRT. That can be rather dangerous. If we take a look at the line cord here, I'll try to get this where you can actually see it. This is a non-polarized plug. And what I mean by that is both of the spades are the same size. On a polarized plug, one of the spades will have a larger end on it, meaning you can only plug it in one direction. This can be plugged in either direction. On the AC wiring coming out of the house, you have a neutral side and a hot side. And that means, depending on which way this guy goes in, one of the terminals up here is going to be neutral. One of the connections is going to be hot. It doesn't necessarily matter to the electronics in the scope. Just because of the way this guy's put together, I have gone ahead, and I'll show you here. It's hard doing this with one hand. I'm connected to the chassis with an ohm meter, and I have looked at both prongs on the incoming power cord, and I can see that neither one of them is directly connected to the chassis. So I know this doesn't have what's called a hot chassis. A hot chassis being the sheet metal, and the chassis is hooked to one side of the line cord. With a non-polarized plug, that can mean that the chassis becomes the hot 120 volts, or it becomes the neutral depending on the direction the plug is in. It can be quite surprising. And this is where you can get into those situations where if you're not thinking about it, you can end up with hot chassis at 120 volts. You can be coming over with your nice scope probe with a nice grounded outer BNC and connect it up and blow the front end out of your scope, cause a nice short, melt down your probe, etc. In this case, the chassis doesn't appear to be hot. I will still use an isolation transformer when I power this thing up, just for safety. An isolation transformer is simply a one-to-one transformer, 120 volts AC in, 120 volts AC out, but it completely isolates both prongs that the power plug could go into from the connections back to the wall. Makes things a little safer. I did go in and take a look and found this interesting. Down here where the negative terminal comes through, there is that nice little nylon spacer, insulator. However, it is connected directly to the chassis. Come up here and take a look. It's a direct short. And we can see that it is because the ground wire comes up to this solder position right here, and the two ends on this little barrier strip go to the screws underneath to mount it to the chassis. So that point is ground for the input, which is perfectly okay. Because it's isolated from the line cord. I don't necessarily have a hot chassis situation where I'm going to blow something up or shock myself. In the little manual, there was a parts layout for the wiring underneath. This is pretty close to what I saw there. It certainly needs some work. I don't remember which one of these guys I unsoldered and the other one was actually loose on its own. It's been a while since I've poked inside. I did order a few replacement caps off of DigiKey quite some time ago. I haven't actually got around to moving any further forward beyond just kind of doing a quick intro video, and we'll pick up the work in a later video and see if we can bring this guy back to life, do something with it. Thanks for watching. Actually, before I go, I thought I'd just give you a quick peek at the capacitors I ordered on DigiKey. Cannot guarantee that these are going to be the proper types of capacitors for the replacements. I just made a quick guess online and ordered. We've got some film caps, 0.22 microfarad at 1 kV. A couple of aluminum electrolytics, 10 microfarad at 450 volt. A couple again of film capacitors at 10,000 picofarad, 1 k volt. Again, and some radial film capacitors that are 0.1 microfarad at 1 kV. So the caps I ordered are rated much higher than what was actually in circuit. It's never a problem with the capacitor. Overrating the voltage. You want to keep the capacitance pretty much the same, but if you go to a higher voltage, it won't hurt anything. Go ahead and take a quick look at the little schematic that come with it. It's nice that it's actually got some waveforms shown in there for troubleshooting. You know, it's not overly complex. Is what it is. You know, vertical, we can see here the ground point I had pointed out is actually to chassis ground. You know, no real surprises in this that I see. Here, of course, is the line voltage coming in, and we can see that in the schematic it actually does go through a transformer, so in no way would this be a hot chassis, and that the primary winding of that transformer is completely isolated from the rest of the circuit. We've got, of course, the filament voltage tap on it. We've got a 6.3 volt tap for V3, and we've got our high voltage tap up here above, which ultimately drives all the high voltage stuff, obviously. Sometimes I do state the obvious. Thought I'd go ahead and give you a shot as well. There's a photograph in the little manual of the assembled chassis underneath, and there's what our chassis looks like in comparison. You know, pretty similar. We do see some differences. We can see that there's a rolled film cap here, there's a dipped here. You know, there's obviously some differences. I'm going to spend some time looking at this. Again, it's been a while since I've looked at it. But, you know, it is what it is.